Hello, can you hear me?
We can hear you.
How are you guys doing? And yeah. So today, let me show you what we have today. So for this is week 14. And this is what you need to do this week. Chapter 8. And then the assignment, 3 assignments, classwork 12, homework 8, then the project. Now, like I said, I'm going to make a video about this project. I will try and get that video done this weekend so that you can start working on it, watch the video, and follow the direction from there to complete the project. So what I'm going to do in the video is a similar project. Then you can follow my directions there to do your own. All right, let us begin. Today we are looking at the test of hypothesis. A hypothesis test, a statistical hypothesis is a claim about a population parameter. So that claim may be true or false. And of course, when I say population parameter, I'm talking about the mean, standard deviation, and proportion. I mean, the other parameters like median, the population parameter have it. Now, what we do when we test hypothesis, we define the population and specify the parameter we want of study. Then we state the hypothesis that revolves around that parameter. And then we give the significance level alpha. Now, this alpha, we met it before when we are doing the confidence interval. If your alpha is 0.05, that means you have 5% chance of being wrong. And if your alpha is 0.10, that means 10% chance of being wrong or committing an error. Then we select the sample from the population and then collect data on that population. After that, we perform the calculations required for the statistical test. Then we reach a conclusion. Now, usually, in fact, all the equations you will have here in this course, you'll be given the summary statistics. So all you have to do is to run the test, state your hypothesis, run your test, and conclude. In statistical hypothesis testing, we use it for many things, a lot of things. For example, we might use it to answer questions like this. Does a particular medication lower patient's blood pressure? Does seatbelt reduce severity of injuries caused by accidents? Or does the public or the customer prefer a certain color in a new line of fashion? So at this time, we are ready to look at the types of hypotheses we have. We have 2 types of hypothesis. One is the null hypothesis. That's the first one. We use HO to represent the null hypothesis. The other one is the alternative hypothesis. Now, the null hypothesis is a statement that the population parameter, the value of the population parameter equal to some specified or claimed value. So that's what you do in null hypothesis. That the value of the population parameter is equal to some claimed value. So now we use the symbol equal, greater than or equal to, less than or equal to when we state null hypothesis. The alternative hypothesis is just saying the opposite of the null hypothesis. And for that, in other words, the alternative hypothesis is a statement that the parameter has a value that is somehow differs from the null hypothesis. So we use these symbols, not equal to, greater than, less than, to state alternative hypothesis. Now, remember we have our alpha here, as if and I mentioned that if it is 0.05, for example, that means your chance of being wrong or committing an error is 5%. So what kind of error are we referring to? That will lead us to types of errors. We have two types, type 1 error and type 2 error. Now, type 1 error occurs if we reject the null hypothesis that is true. If the null hypothesis is true and we rejected it, we have committed type 1 error. Now, type 2 error is committed when we reject null hypothesis. Sorry, when we do not reject null hypothesis when it is false. Now, let me use this matrix to show you how it works. If HO is true, but we rejected it, we have committed type 1 error. But if the HO is false and we reject it, you can see reject HO, we have made a correct decision. Now, if the HO is true and we do not reject it, it's true and we are committed, it's true and we didn't reject it, that means we made a correct decision. And if HO is false and we did not reject it, we committed type 2 error. So now these are the types of error we commit. Now I'm going to show you, I'm going to use a real life situation to explain this more. I'm going to use jury duty, or jury trial. Now, in a jury trial of a defendant, there are 4 scenarios. Either the defendant is guilty, or the defendant is innocent, or the defendant is convicted, or the defendant is acquitted. Okay? These are the 4 scenarios. Now, this is a hypothesis. No, is that the defendants hello? Okay. Is innocent. The alternative remember the alternatives say the opposite of the no. The defendant is guilty. Is guilty. Now, the state attorney will now present their case. Now, HO true means that the defendant is innocent, and HO false means that the defendant is guilty. Reject HO means to convict. Do not reject HO, it means to acquit. Now, if the defendant is innocent, that means HO is true, and we reject it. That means convict the defendant. That means we are convicting an innocent defendant, which means that we have committed type 1 error. And we know that this can happen sometimes. I've seen it on the news sometimes ago, where people who are sent to put jail spend almost, some of them spend almost 20 years, even 30 years, only for the DNA test to clear them, and they are released. So this kind of thing can happen. If the defendant if the HO is false, that means guilty, and we reject it, which means convict the defendant, and then we have correct decision. Okay. So here the defendant is if the HO is true, that means the defendant is innocent, and we do not reject HO. That means we acquit. That means we made a correct decision. Okay, I write decision right wrong here. Made a correct decision. Correct decision. Okay. Now, if the defendant if HO is false, that means guilty, but we do not reject it. That means we didn't acquit. You have committed we do not reject him. That means we let him go or let her go. We acquit, even though he's guilty or she's guilty. Committed type 2 error. 2 error. So that will give you an idea what this is about, what these type errors are about. Now remember that the decision of the jury does not prove that the defendant did it or commit the crime or not. The decision is always based on the evidence that is provided. So if the evidence is too strong, then they can be convicted in most cases. Anyway, I think you get the point. Any question on this? Yeah, excellent.
I don't think I understand it at all, actually. I mean,
okay.
Well,
go
first
ahead.
of all, why I don't understand what this means to reject or not reject your own hypothesis.
The hypothesis, you make a claim, then you test the claim. If the claim is incorrect, you reject the hypothesis. So
right,
that is where the reject and not reject come from. So we normally state the 2 hypotheses, H1 and H1. One of them will be a claim. Like if your claim is here in the HO, that the defendant is innocent, and that means HO is true, and you reject it, that means you convict the defendant. You have committed an error. But if the HO is false, that means the defendant is guilty, and then you reject HO, that means you convict him or her, you have made a correct decision. So, and so on and so forth. Now, you are going to understand it more when we start testing hypothesis today. You get an more idea of what we are doing, okay?
Okay.
So now, another question before we move to the next, to show you how to state hypothesis.
When are you opening up assignments for us?
Don't say, I keep telling you, don't say us, Miss Elliott, say me. So
yeah, for me.
This is the week.
When can I open up the?
This is the week. So choose 5 assignments that you want to redo. Okay, then email it to me.
Okay.
Your
and then how long do we have to redo them? The week?
A week, yes, of course, a week. Now, remember, your uncles, I know that I see you all the time. You and Mr. Dwayne. Dwayne, are you here? Dwayne? Oh, he's not here. I see you guys every day, so I don't even need to verify. But the other ones, my class, hello, can you guys hear me?
Yes, we can hear you.
Good. Now, if your attendance is up to 70%, and they have sent me email with 5 assignments. Remember we had an agreement. So I always like to keep my word. So send me an email about 5 assignments that you want to redo. Okay. Remember, each assignment has a name. So you have to mention their names. If it's homework 1 or homework 2 or test 1, where I can only do test 1 now, but I don't normally do it for test, but I can do it for test 1 now. But classwork 1 or Excel assignments, so they all have a name. You have to be specific. Now,
so no Alex assignments?
Huh?
So you're not opening any Alex assignments?
Homework is Alex assignment. The homework is Alex assignment. Yeah. But your attendance have to be up to 70%. I'm going to update it after the class today. I'm going to update it again. So if it's up to that 70%, you can now. Miss Green, are you here? Can you hear me, Miss Green?
Yes, I'm here. I can hear you.
Miss Green, your own is different. You can just email me anyway.
Okay, great.
Yeah, your own is different. So,
Professor, I have a question.
Yeah.
So I'm not sure why my attendance is back at like a 69.
What's your name?
Roberts.
Yeah, probably when Roberts, last name is Robert. Okay, I didn't see you on Friday the 5th.
I was there because I asked you several questions.
Maybe see.
I
So
asked you like 5 questions.
you say it's I didn't see it. I didn't see it right here. If you can go to the video for that week, the date is
Yeah,
the date is you know, for a month, April 5th. And
okay.
show me the clip where you ask, I mean, yeah, you know, then I'll
Of last, you're saying
Mhm.
last Friday, correct?
No, not last Friday, April 5th.
April 5th. Okay.
Yeah,
All right.
last
Yeah,
Friday,
I'll do
last
that.
Friday you were here last Friday. This is Robert Phillips, right?
Yes.
Yeah. Probably there's somebody that comes in what you wish I will be seeing iPhone. Is that you?
Yeah, usually it is me.
That's why that's why. Because last week
Okay, well,
I saw I didn't know who I was asking. Who is this person?
okay. So I'll go in for not this week, but the Friday before.
Yeah, fit. Then if you can get that section, then I'll upgrade it. In any case, when I update it to 9, if it is 6-9, if I update it to 9, that means it's gonna be 70 anyway.
Okay. All
Yeah.
right then.
All right, guys. Any more questions any more questions have to come. If it's not related to the work we are doing now, then you wait on the end of the class. You can ask me. Okay. All right. Let's see how to test hypothesis. I mean, how to state hypothesis. Remember that for the null hypothesis, these are the symbols we use when we state null hypothesis: equal, greater than or equal to, less than or equal to. You cannot use any other symbol in the null hypothesis except these ones. For the alternative, equal, greater than, less than, you cannot use any other symbol for the alternative hypothesis except these ones. Don't forget that. Now, let's begin. The first question says, state the null and alternative hypothesis for each conjecture. This one says, a researcher thinks that if expectant mothers use vitamin pills, the birth weight of their babies will increase. The average birth weight of the population is 8.6 pounds. Excuse me. So in this case, have your HO, which is not hypothesis, and H1 is alternative. So this research think that if the expectant mothers use vitamin pills, that the birth weight for the babies will increase. This is the keyword right here. Will increase. And increase means greater than, which can only be used in the alternative hypothesis. So that means we have it as mean greater than 8.6 pounds. Okay, which is the claim that he's making or she's making. Then the null hypothesis say the opposite. That means that mean will be less than 8.6 pounds. But the problem is that you cannot use less than symbol in the null. You can only use less than or equal to symbol in the null hypothesis, which is 8.6 pounds. And that's it. We have stated the hypothesis. Any question? Any question? Good, excellent. Now let's try another example. It says here, there is such a claim that the mean number of defects can be decreased in a manufacturing process for compact discs by using robots instead of human beings for certain tasks. The mean number of defective discs per 1,000 is 18. So he said that this defect can be decreased. That's the keyword there. So you have your HO and H1. Okay, can be decreased, can be symbol, can only be used in the alternative. So we're gonna put mean, okay, less than mean defects. Now, because they say that the average defective per 1,000 is 18, so mean less than 18. That's a claim right there. The other one will mean greater than 18. We mean greater than 18. But you cannot use greater than in the null hypothesis. You can only use greater than or equal to 18. Okay. Now, this claim can also be in the HO. Sometimes it depends on the way the question is worded. If you look at this one, the claim is here, and this claim, the symbol there is pointing to the right. So that this is a good example of a right-third test. Because it's pointing to the right. Okay. In this case, the claim, the symbol is pointing to the left. This will tell us that it is a left-third test. Test to be done here. Okay. All right. Now, I look at this one here. It said that the psychologists feel that playing soft music during a test will change the result of the test. The psychologist is not sure whether the grade will be higher or lower. But in the past, the mean score is 73. She said that it will change. Will change. That's the keyword, right? Will change. So now it doesn't tell us whether it will gonna increase it or decrease it. Just say we change. That means it can be either increase or decrease. So that means we have two sides to it, either it increase or it decrease. So that gives us a two-terror test. So that means HO and H1. So these psychologists feel that we change. The symbol gonna be not equal to, which can only be used in the alternative. Mean, okay, not equal to what then? Well, it said that in the past, the mean score was 73, so not equal to 73. That'll be claim. Then H1 will be, HO will be saying the opposite, which would be that the mean will be equal to 73. So now it is not equal. That means it can be left side or right side. So we call this type a two-third test. Okay. Now, so now we're not gonna be doing proportion. So we're not gonna waste our time with proportion. Look at this one here. It says state null hypothesis to on this case, we can say, okay, H solution. This one says that the average annual income of accountants is 51,497. So this one means equal, and you can only use equal in the null hypothesis. Okay. So you have that the average, which is mean, equals 51,497, and that is the claim right there. Okay. H1 is that mean is not equal to. Is not equal to. Okay. All right. See, 51,497. See? So as you can see, the claim can either be in null or it can be in the alternative, depending on how the question is worded. Again, this one can be both sides, can be equal, can be left or right. So this is a two-thirds test. Any question in what I just did?
Yes, why is it a two-tailed test?
Well, if you look at this one, let's start from the beginning. If you look at this one, This is the claim, right?
Uh-huh.
That's the symbol in that claim. That
So
symbol
you're gonna
is,
shade the area to the right of 8.6 pounds. That part makes sense.
yeah. Okay, you understand it now.
That part makes sense. Go back to the one with the two tails, though.
Oh, this one. Okay, this one. You can see the claim right here, right? And
Okay.
it say will change. That means it doesn't say it can change. It can be both sides. It can be backward or forward.
Okay.
That make it two sides, two tails.
Okay.
And this one, same thing here. If I see is, it can be either way. It can be 51,000. If you look at the here, I say is 51,497. So it can be
Okay.
either way. Okay. That make it two tail tests. Good.
Okay.
Very good
Are
question.
you gonna show us how to do the two-tailed test?
Yeah, we're gonna do both of them.
Okay.
So now let's look at a few terms we use when testing hypothesis. The first one is the level of significance, and we use alpha to denote that. We have seen it before when we are doing a conference in Taba, and I explained it today when we are doing types of errors. See, sorry, not type of error. When we are doing when I introduce test of hypothesis, the significant level alpha. So as a matter of fact, when we are doing types of errors, because type 1 error has to do with significance level. As a matter of fact, the significance level simply means the probability of committing type 1 error. You can see right here. The probability of type 1 error is alpha, which is the significance level. Now, critical region is the name given to the rejection region. If your answer falls in that region, you reject null hypothesis. And then the critical value is just the line of cutoff line, the line of demarcation between the critical region and the non-critical region, called the critical value. You can see right here. For two-tailed tests, the yellow part is the acceptance region. If your answer falls here, you do not reject null hypothesis. But if your answer falls in this blue section, this line here represents the critical value, but the whole of this section include the critical region. If your answer falls there, you reject null hypothesis. Similarly, on the left side, if you fall in this region, you reject null hypothesis. Now, for one-tailed test, like this left-tailed test, you can see the critical value right here, and if you see the red portion, the answer falls that you reject it. For right-tailed test, if you fall on the critical region, you reject it. So, having said that, we are now ready to test hypothesis. We begin with what is called the z-test for the mean. The z-test for the mean. There are two methods. One is the traditional method, and the other one is the p-value method. Let's do both methods. For the traditional method, the steps goes as follows. First of all, you state the hypothesis and identify your claim. Then find the critical values from the appropriate table. And I've shown you that table before. We used it before. So once you state your hypothesis, you find the critical value using this table. You are familiar with this table. We've been using it. Yeah. So next is to compute the test, but that is run the test, basically. Then make a decision to reject null hypothesis or not to reject null hypothesis. Then summarize your results. Now, how do you decide to reject? Call it decision criteria. You reject the null hypothesis if and only if the calculated value, that means your answer, is equal to or exceeds the critical value. So when your answer is equal to the critical value or your answer is false in the critical region, you reject the null hypothesis. Otherwise, don't reject it. Yeah. So that's what it means. That if your answer falls in the region, reject. So let's look at the formula for we call it the test statistic. Z equals X bar minus mean divided by standard deviation over root n. Again, we have come across this. You have come across this formula before when we are doing central limit theorem, where S bar is the sample mean, mu is the population mean, delta is the population standard deviation, and n is the sample size. Okay. So we can now try one question here. One for actually two. One for 1 tail test and one for 2 tail test. Let's begin. Okay. We have that. It says here that a researcher wishes a researcher report that the average annual salary of assistant professors in the year during the year 1997 is more than 42,000. A sample of 30 assistant professors has a mean salary of 43,260. At alpha 0.05, test the claim that the salaries of assistant professors at that time in 1997 is 42,000. So somebody just came in. Oh, okay. All right. So let's begin with that. First of all, we are told that we need to state a hypothesis first. Identify our claim first. HO H1. Now, have that. You see that test the claim that the assistant professors earn more than. That they earn more than. Okay. Earn more than. See, that's where the claim is lies. Okay. So that means more than means greater than. So we have mean. Let's still hypothesis mean. Okay, greater than. Okay, 42,000. Claim. Okay. Now, no, I will say the exact opposite, which is that mean is less than $42,000. But you cannot use less than in the null hypothesis. You can only use the less than or equal to. So you're gonna have that mean is less than or equal to 42,000. Okay. Now our alpha will now become this, and this is, as you know, this is a right tail test, because consider the claim the symbol is pointing to right tailed test. So now we have that in mind, we can now list our summary statistics. So they say that the mean is 42,000. So let's write down the summary statistics. Mean is 42,000. And then the example of 30 assistant professors were selected, N equals 30. And the sample mean, the mean of their salary is 43,260. We cannot get the character for the sample mean here, so we're gonna get it from a different. Let me get the paper here. We're gonna get it from a different. That's something here. Workbook X bar equals, say, 43,260. And then population mean is 42,000. And N is 30. Okay, let's for the standard deviation is giving us 5,230. So using this, we can now go. Let me go and get the sample mean. That's this one here from the other workbook. I'm going to show you how to get it. I mean the character for sample mean. So you have it's right here. So the sample mean, you have this equation, S bar. I'll make it 18. So S bar equal says 43, 260. So I'm gonna copy this and we're gonna paste it into our main workbook. So we have the summary statistics. Now we are now ready to run the test. And so the test statistics, like I explained, the test statistic is this: z equals to S bar minus mean divided by standard deviation over square root of n. So let's go to where we can get it in that form, which again is this form, this formula here. So you have z equals I'll move this down. Z equals we got put the parentheses S bar and our mean divided by standard deviation over square root of n. Okay, standard deviation of delta for the square root of n. Which is S bar is, as you can remember, we have the summary statistics in the other work we consider right here. S bar is 43,260, n is 30, mean is 42,000. Then alpha. There's one more thing we're looking for. Standard deviation. We need standard deviation here. The standard deviation is equal 5230. I'm gonna adjust this. Okay. Let's go and put this in the formula and get our Z. So you have 43, 260, and 42,000 divided by standard deviation over square root of n, 5230 by the square root of n. N is 30. So you can go and put this in a calculator to run the tests. So we got Z equals 43, 260, and 42,000 divided by standard deviation of 5230 over root 30. Okay. Let's go and put this in the calculator. We'll get answer right away. So you have 43,260 and 42,000 divided by 5230 over square root of 30. The 1.32, actually 1.31956. So when you round, it's going to be 1.32. So I'm going to let's go and put it there, 1.32. 1 point. So that's the result of our test. Let's go and put it here and make our decision. Right, our book, okay, right here. So make a decision. So now how do we make a decision? First of all, let's find the critical value. Matter of fact, we should have found the critical value first. So let's find the critical value. The critical value Z alpha critical value Z alpha over 2 alpha over 2 not alpha over 2, because remember this is the right tail test, so it cannot be alpha over 2. So you gotta be only one alpha. Z alpha. It's a right tail test. So Z alpha equals, let's find it. Now, before we can find it, we'll make a drawing here. We draw the chart for this. You see that we have 0, and we have the critical value we are looking for, Z alpha. Z alpha. So if we put the chart here, suppose we put this chart on this section. Okay. Then put the bear curve from here. Okay. And then put the center line. Then move it back a little bit. Okay. Then and also put the line for the Z. No, that we have Z alpha equal. I'm gonna get it here. Okay. Now you have let us share this rejection region. This is the region we shared. The answer falls on this critical region. Okay, if we fall on it, we reject null hypothesis. If it doesn't fall in it, we don't reject it. Okay, all right, let's do this. So this area is the rejection region. So that's what it is. So that's it right there, the rejection region right there, or critical region. So I can call it critical region. That's what you call it. Critical region. So if your answer falls here, you reject it. Now, let's find the critical value. Critical value is going to be right here. See the line, this line here, the cutoff line. That's the critical value. Now, let's find it. Like I say, it's not if it is a two-tail test, you can find the critical value the same way we found it when we are doing confidence interval. But this is not this is a right tail test. And in that case, remember I explained when we are doing normal distribution is that if that's answer for in the tail, you subtract from 0.5. So 0.5 minus 0.05. That is this is alpha 0.05 right here. That's the probability. So you can see right here, 0.5 minus that gives me 0.5 minus 0.05. Let me put it this way. And I'll take it to 0.5 minus 0.05. Okay, 0.5 minus 0.05 give us 0.45. So we're gonna get 0.45. We're gonna go and put it right there. 0.45, 0.4500. Now we can now go and look for this on the table to get a critical value. Go to our table of normal distribution. 0.4500. We have 4500. So you have 450, okay. So I think we have two numbers that close to it, 4495. If you ignore decimal point, see this one here, and 45. So both of them are this one is 5 points away. As you can see, if you do 4500 minus 4495. See if you ignore decimal, 4500 minus 4495 is 5 points away. The other one is also 5 points away. This number here, 4505. So this one you can even see it. 4505 minus 4500 is going to be 5 points away. So when they are equally close like this, choose the bigger number, which is this one. Follow it to the left, 1.65. So 1.65 is the critical value. 1.65. So 1.65. So now our answer from the calculation is 1.32. Let's make a decision. We can now make our decision. So remember how we write our answer. Well, let's write the critical value. Critical value can say critical value Z alpha is equal to, we got 1.65 for it. Then the calculated Z value, which is our answer, calculated Z equal. Our answer that we get from the calculation is 1.32. 1.32. So what will be our decision in this case? Now, before I can answer that, I want to remind you of how we make decision here. This is the process. It says here, reject null hypothesis if the calculated value, that means your answer, is equal to or exceed the critical value. Now, in this case, our answer is not. Okay? Our answer does not exceed the critical value. You can see right here. The critical value is 1.65. And our answer is 1.32, which is less than the critical value. In that case, we don't reject. Do not reject null hypothesis, because the critical value of 1.32 is less than the our answer. So because the answer, sorry, not the critical value. The calculated value, the calculated value of 1.332 is less than the critical value, less than the critical value of 1.65. So our answer, which is the calculated value, is less than the critical value. So we don't reject HO. So that means we did not reject this. That means this one is incorrect. So that means the claim is not correct. So our final answer, please, can you mute yourself? So the conclusion becomes that. So again, since we did not reject this HO, that means this is the H1 where the claim is. Since we are not rejecting this, that means that this one is wrong. So that means there is not enough evidence to support the claim. So we say that there is insufficient evidence. Okay. There is insufficient evidence to support the claim that that the assistant professors earned more than for 2019-97. So I'm gonna copy it and write this. That assistant professors they earn more than that assistant professors earn more than for 2000 in the year 1997. So that's it. That is what it is. Any question on that?
Did you get the critical value by subtracting the alpha from
Yeah, remember,
whatever the rule is for the tail?
yeah. Remember that alpha is the probability of committing type 1 error. So, and when
Okay.
whenever it's at the tail, if you remember when we were doing a normal distribution, remember when I asked you to compare the chart to this. So
Right.
at the tail, we subtract from 0.5, remember, and then get it.
Okay. And you just subtracted the alpha from it, right?
Mm-hmm. Then we're gonna look for it
Okay.
on the table. This is
Okay.
this table. So yep, if you're using this table, that's how you're gonna do it. If you're using the cumulative one, there's a different way you can do it. So that's like I mean, if you're comfortable with that, fine. All right, since there's no question, let's try the one that you can see. This one is a right tail test. Let's try the one that is 2 tail test, like this one here. It say that the Medical Rehabilitation Education Foundation report that the average cost of rehabilitation for stroke victims is 24,672. To see if the average cost is different at a particular hospital, a researcher selected a random sample of 35 stroke victims at the hospital and find that the average cost of their rehabilitation is 25,226. The standard deviation of the population is 3,251. At alpha 0.01, can it be concluded that the average cost of rehabilitation is different, say different from 24,260. So this one is two tested because it says that can it be concluded that the average cost of rehabilitation at the hospital is different? I mean, it can be less or greater. It's different from 24,000. That's 250. So 24,670. So that is the claim right there. Again, the first thing to do is to state the hypothesis, identify the claim. But let me move this. Okay, let's just start from here. Solution. We have our HO and H1. So it's different. Different. That means not equal to, and we can only use not equal to in the alternative. So I'm gonna put it right there. Mean is not equal to 24,000 672. Then H1 we say that is different. Now HO, as usual, we always say the opposite of HO of H1, I mean to say. So to do that, let's put it here, and then so the opposite is that it not is equal, so that the mean is equal to 24,672. But it says that can we be concluded that the average cost of rehabilitation at a particular hospital is different? So that means the claim is right here. Claim. Now, since it can be either side, this is a two-tailed test. Two-tailed. test. Okay. Now let's all read our summary statistics here. It said that our alpha is 0.01. You can see right there. Okay. Just copy that and paste it here. Alpha is 0.01. Okay. The mean equals, okay, equals, it says 24,672. Then it's a sample of 35 stroke victims. N is 35. And then they found that the sample of that 35 people is 25,226. So I'm going to write it down. Let me write all this down. Mean is 24,672. N is 35. Then this other one is the sample mean. Okay. For the sample mean. So let's go to where it will allow us to put it. Sample mean gonna be here. X bar. Okay, X bar equals from our chart. Let me get everything in our chart. Okay. Just come on. Okay, this thing doesn't want to go. Post on look here. So now we have X bar is 35,000, sorry, 25,226. Let me write it down. 25,226. Taking you there. So we can put it in. Where's my book? 25,226. So I copy this. Paste it there. Okay, right there. So we have everything. Then standard deviation is what it needs. Is now the standard deviation is 3,251. Standard deviation is 3,251. The standard deviation symbol is right here. Three, 2, 5, 1. Right, just this. Okay. It says, is there, can it be concluded that the average cost of rehabilitation at a particular hospital is different from 24,672? So now let us run the find a critical value before we run the test. So the critical value, critical value. Critical value. Now this one is a two-tailed test. See, can be it is a two-tailed test. We can find the critical value the same way we find it when we're doing confidence interval. So that will be Z alpha over 2. Alpha over 2 equal. Okay, they put it in. So is alpha point. See, 0.01 means that you are 1% chance of committing type 1 error. So your chance of being correct is 99%. So this is gonna give us 99 over 200. Remember, 100%. 100% is 99% is only is 100% is over 100. But since there are two sides now, that's why we're using 200. I mean, it's a shortcut method. So we have 99 divided by 200. 99 divided by 200. Yeah. What is it? Where are we on something? So now let's do it. 99 by 200. So we go here and find 99 by 200. Okay, 0.495. 0.495. Can go and put it right there. 0.495. 0.495. 0. So which from the table? Now we can go to the table and get it. 0.495. So how 0.495. Okay, I saw 0.4951 here. Okay, if you follow it to the left, you get 2.5. 8. 2.5, it will get 2.58. $2.58. Now we have our hypothesis stated, have our summary statistics, have our critical value. Now we're ready to run the test. So let us run the test. So remember the formula is that it is Z equals S bar minus mean divided by standard deviation over root n. So let's go and put all this in the calculator. Let me write this down. I got some of them in. I only need, I have everything written down. 3251. Let's go and put it on the calculator. So you got let's go and put it on the formula paper. So that Z equals, okay, S bar minus the mean divided by standard deviation. Okay, standard deviation is somewhere here. Oh, it's gonna make a mistake. I'm gonna put this first. Standard deviation is this right here. By the square root of n. Which is, so putting all this together, we got S bar is 25,226. And our mean is 24,672 divided by the standard deviation over root n. The standard deviation is 3251 over square root of x, and x is, of n. N is 35. So let's go and put this in. Oh, I didn't put square root of 35. Square root of 35. 35. So I'm gonna correct it again. 35. So let's go and put this on the calculator. Let me write this down. Z equals 25,226 and 24,672. For the standard deviation of 3251 for root n. Okay, and n is 35. Let's go and put it on the calculator. Uh, 25,226 minus 246 72. Okay, 246 72. Okay, divided by the standard deviation of 3251 over the square root of 35. 1.00815 and so on. So you round it, if you round it to the 2 decimal places, it's going to be 1.01. So it's 1.01. Okay. 1.01. Let's take a look at it again. Make sure we've got the right thing. Yep, everything looks good. 23251. Yeah, we got 1.01. Okay. Now, I have written it here, so I'm gonna just copy it. Copy this, and then paste it where it should be. Okay. Paste it here. So now, at this point, now we have everything. We're ready to make our decision. We have our hypothesis, smallest statistics, critical value. We have run the test and we found that it is 1.01. Let us make a decision.
Your screen is still on the formula.
Huh?
Your screen, you gotta go back to the workbook.
Workbook. Oh, okay. I gotta put it on workbook. Right here, right? You can see it now, right?
Yes. Yeah.
So we have the critical value, the hypothesis states, the smallest statistics, critical value. We have the result of the test. Now let's make a decision. Now our critical value Z alpha over 2, this is the two-tailed test, equals, we got it as 2.58 right here. Okay, but the calculated value, yes, our answer. Calculated Z equals, excuse me, equals 1.01. Okay, so our decision now since again, remember the decision, if it is answer is in the critical region, I mean if it's bigger, see, look at this, our answer is less than the critical value, so we cannot reject null hypothesis. So do not reject HO because your answer, which is the calculated value of 1.01 is less than the critical value of 0.58. Okay. Now, sometimes the answer, remember, this is a two-tailed test. And if your answer, let me show you something. This is a two-tailed test. Let's say that your answer is, let's say that we have the chart here, for example. I just want to show you something. 0, that means it can be, this is critical value. Critical value can have to be plus or minus because it can be either side. But our answer is positive, so we have to take the positive side. If it's the negative side, that means negative 2.58. Use the absolute value of it, which is 2.58, to get it. Yeah, okay. I mean, to get it, make a decision. So we don't, in this case, we don't reject. We do not reject. So what I wanted to show you was that since the critical value is 2.58, it can be plus or minus 2.58, which is negative 2.58 on the left side. On the left side, and on the right side, we got to 2.58. Okay, and then we can then where's my attendance? Then we can then draw the charts easily from here. You have the chart. It looks like this. And we have the center line of this. We have the left critical value. We have the right critical value. So we can shade both sides. Okay. 2 more. On the right side, you have the same thing. Okay. All right, 2 more. So you can see that it has 2 rejection regions. Rejection critical regions. It has 2 of them. You have critical region here too. So this has 2 critical regions. One is right on the left side, which is negative. And the other one is on the right side, which is also is positive. So remember, because it's 2 terms, if your answer is negative, let's say we have negative 1.01, that means you're going to use this one. And then you can use the absolute values to get the answer. So, but in our case, it's positive. So we use the positive side, which is 2.58. And we do not reject the null hypothesis because our answer is less than that. If your answer is equal to that, to critical value, or if it's more than that, you reject null hypothesis. So let's make our conclusion here. Conclusion. Okay. Now we did not reject hypothesis. So we did not reject this. That means this claim is also incorrect. So we can now state that conclusion. There is not enough evidence. There is not enough evidence. Okay, to support the claim. Support the claim that, which is that, this is where it starts. To support the claim support the claim that, and what is the claim? The claim was that the average cost of rehabilitation of stroke victims in that hospital is different from 24,672. Since we have it there, I can just go there and, I'll go and then copy it in. So have that there is not enough evidence to support the claim that the average cost of rehabilitation of stroke victims in that hospital is different from 24,000. See, I had a clear idea. There's enough evidence to support the claim that the average cost of rehabilitation at a particular hospital is different from 24,670. So that's how it goes. You make a hypothesis, get a critical value, run the hypothesis, make a decision, then conclude. Any question to any of this? Any question? Any question? Okay, good. Now, remember the one we just did is called the z-test for the mean, the traditional method. Now let's do the p-value method of the same thing. P-value method. So this z-test for the mean using the p-value method. Now in this case, you're not using the critical value. You are using the p-value. P-value simply means the probability value. But otherwise the principle is the same. State the hypothesis and identify a claim, compute your test, find the p-value, make a decision, summarize results. For the p-value, the decision criteria is different. It says if the p-value is less than or equal to alpha, reject my hypothesis. But if the p-value is greater than alpha, don't reject. Okay, let's see how it works. This example here. Say that a researcher wishes to test the claim that the average age of lifeguards in Ocean City is greater than 24 years. She selects a sample of 36 lifeguards and find the mean of the sample to the 24.7 years with a standard deviation of 2 years. Is there enough evidence to support the claim at alpha 0.05? Okay, use the p-value method. Now, okay, so again, like I said, the principle is the same. You state the hypothesis HO and H1. Said a researcher wishes to test the claim that the average age of lifeguards in Ocean City is greater than 24 years. Greater than 24 years. Okay. Now, greater than is a symbol that will be used, can you use only in the alternative hypothesis. So we're gonna have it there. Mean is greater than, what is it? Oh, I'm putting it in the wrong place. Okay, I'm gonna put it in the right place. That's mean is greater than 24 years. Yeah, then the null is just the opposite of that. But the only problem is that we can't put less than symbol in this null. You can only put less than or equal to. Okay, I'm gonna put it mean is less than or equal to 24 years. So this is, but he was trying to test the claim that the average age of lifeguard in Ocean City is greater. So that means it's a claim right here. Okay, and our alpha is given as 0.05. So now we don't need critical value because p-value is what we are looking for. So what you're gonna do now is to release the summary statistics. Okay, we have mean is 24 years, mean 24, and they selected a sample of n equals 36 lifeguards. I found the mean of that one, which is X bar. So I'm gonna write this one down as well. Like that. Mean is 24, N is 36. So S bar, let's get it as a sample. The sample mean is actually given here for the sample of 36 lifeguard. The mean is for 24.7 years. So S bar is 24.7 years, 24.7 years. So we have to go to where you can get a character for S bar. So I'll take you there. All right, that's right here. Yeah, we got X bar equals 24.7. Yes. Take you back to the workbook, main workbook. Then standard deviation is given as 2. So delta equals 2. So I'm gonna adjust it. So with this, we can run our test. Okay, oh, excuse me. So let's find our test. We have, remember the formula Z equals X bar minus mean divided by standard deviation of root N. So let's go and get it. From here. So Z equals X bar. So now remember we have all these summary statistics here already. So I think I'm missing the standard deviation. Let me write the standard deviation down. Delta equals 2. So we just got all you have to do is to put them in the formula to get our Z value. We have 25.7. Make sure I've seen this. Okay. Minus 24 divided by the standard deviation of 2 for the square root of 36. So let me write it down so I can figure this out. 24.7 and 24 over 2 over square root of 6. So that 24.7 minus 24 divided by the standard deviation of 2 over the square root of 6. 2.10. Okay. 2.10. So that's our Z. With this Z, we can find our p-value now. So let me go and put it answer in there first for Z. See? Now to find the p-value, let's find the p-value now because we're using p-value method. P-value equal. And to find p-value, see, we need a chart. We have our chart like this. So we got 0, then 2.10. They're on the same side. And also, see right here. So I'm gonna draw this chart. Sure, I've seen this. Okay. So let's insert this. That line. Oh, I put it the wrong one. So I'm gonna try it, correct one, use the correct one. So insert. All right here. Okay. Then get this. Okay. All right. Okay, then put the center line. Okay. The positive side, I'm gonna put on the positive side, this is the tail, the rejection region, and you can just shade it. Okay, shade it completely. All right, this is it. So this will help you to find the p-value. If you remember, when I mentioned when we were doing normal distribution that when it's on the tail, just subtract your answer from 0.5. I remember I mentioned this and we did it several times in that topic. So this is on the tail, just on the tail. See? So the p-value will not be anything we found here. Subtract from 0.5 minus that. 0.5 minus 2.5, what answer we got for 2.10? So we go to 2.1 under 0 in the table. You can see the 0 right here. 2.1. I think it's under 0, under 2.1 under 0. And this is 0 right there. So it's going to be 2.1 under 0. Okay. You follow it on the left. See, 0.4821. 0.4821. Okay. 0.4821. Subtract this from the calculator. 0.5 minus 0.4821. Okay. Yeah, 0.5 is right. Okay, put it right here. 0.5 minus 0.4821. So 0.0179. Write it down. P-value 0.0179. So we're gonna put right there. 0.0179. That's a p-value. Now let's make our decision. We got a p-value because we have our hypothesis stated. We have our summary statistics. We calculated z. We got our p-value. And let's make our decision. Okay. Now, for this type, for p-value methods, remember it says if the p-value is less than or equal to the alpha, reject null hypothesis. So in this case, our p-value is less than alpha. See? So let's see. Let's write it down. Our answer is okay. Let's see. Maybe somebody's coming in. Hold on. Okay. So let's say our answer is our alpha is 0.05. I'll copy it. 0.05. Alpha is this. And our p-value equals 0.0179. So our p-value right there. When you observe this two, you can see that our p-value is less than alpha. And then once again, remember that this way, if the p-value is less than or equal to alpha, reject null hypothesis. So in this case, it is less than alpha. So we're going to reject the hypothesis. Reject the null hypothesis. Because p-value, the p-value of 0.0179 is less than alpha of 0.05. Reject it. So we can now conclude as follows. Conclusion. Now, since we are rejecting the null hypothesis, so that means the claim is right. So rejecting the null hypothesis, the claim is correct. So you can say that there's no evidence to support the claim that the average age of lifeguards is greater than 4 years. So you have there is sufficient evidence to support that claim. There is enough evidence to support the claim that the average age of lifeguards in Ocean City is, okay, it is 24 years, or what the claim is. So in this case, we rejected null hypothesis, which make the claim correct. Now that's how you do the p-value method. Now, the only difference that if this is a two-tailed test, If this is the two-tailed test, that means this answer you got from your p-value, you have to multiply it by 2 to get the final p-value. That's all. Right, that's it. This is how to do it. Any question to this? Any question? Excellent. So let's round up with different kind of tests. T-test for the mean. Now, t-test, we use this type of test when the sample size is small and we don't know the value of the population standard deviation. Statistically, we say that the sample size is small when n is less than 30. We say it is small. So instead of we call it the t-test because we're using the student t distribution table. This one here. This is the table we'll be using. And if it's the two-tailed test, you use this one that have double prime. If it's one-tailed test, you use this alpha that have only one prime. Okay. So that's the t-test for you. So that means the formula is now become t equals x bar over mean. The answer the calculating computational the test statistics now become t instead of 0, have t equals x bar minus mean divided by s over n. This s represents the sample standard deviation because we don't know the value of the population standard deviation. And this s is so it's on this side is the same thing, just that the t z was replaced by t. Now the table that I showed you, we used it before when we are doing a confidence interval, and it's based on the degree of freedom, which is for the kind of test we are doing is given by n minus r minus 1. So let's do 2 examples on that. Let's look at this one. Say a job placement director claimed that the average starting salary for nurses in 2000 is 24,000. A sample of 10 nurses. 10 nurses have a mean of 23,450 and a standard deviation of 400. Is there enough evidence to reject the director's claim at alpha 0.05? So what is he claiming anyway? He's claiming that the average salary, starting salary for nurses, okay, is 24,000. So is means equal, and we can only use equal sign in the null hypothesis. So let's say is 24,000. So I'm gonna paste it. Okay. Now I have HO and H1. Look one. So this one say mean equal 24,000. Mean equal 24,000. That is what he's claiming. So this one said the opposite, which is that mean is not equal to 24,000. Yeah. Now alpha is alpha we have is this. So now then let's find the critical value. Our n equals, see that a sample of 10 nurses, so our n is 10. So then we have that of these 10 nurses has a mean, is S bar. Let me write it down. We have alpha 0.0 equal n is 10. Okay, let's find let us find say that the mean is 24,000, right? Mean is 24,000. So it's after selecting a sample of 10 people, And you find out the time after this 10 people, their mean is 23,000. So that sample mean is 23,000. So let us find this. Okay. So sample mean, let me go and get where I can get a character for this. So that means I have to write it down then. I can have it here. X bar is 23,450. And sample standard deviation is 400. Okay. Let me take you to where we can get the sample mean character for sample mean. You can get it from there. Okay, we have X bar equals 23,450. Okay. 23,450. We have it right here. And the standard deviation, this time around, we're using sample standard deviation. So we're going to use S equals 400. S represents sample standard deviation. Now, let's find it. Since I'm using the table, this table here, the student T distribution. So it is based on the DF, which is the degree of freedom. So like I said, we used it before. You are familiar with this table. So I won't waste so much time on showing you here. So we have okay. So the degree of freedom, DF, equals n minus 1, which is our n. Okay. Our n is 10. That means 10 minus 1. So the critical value, this time we have become T alpha. This one is a 2 terabyte because this one is equal. The other one is not equal. So this is going to be a 2 terabyte text. So this time we're using it at where the alpha is 0.05. Anyway, alpha over 2. That's what it's going to be. Alpha over 2. That is the critical value. Let me call it again. Critical value. So I'm going to adjust this a little bit. So we're going to look under 9 degree of freedom at alpha 0.05. So we go to here. Okay. 0.05 is right here on 9 degree of freedom. I think it's here. Yep, free to the left. See, 9 degrees, alpha 0.05. Let me make sure I have the correct alpha here. Okay, alpha, yep, 0.05 and degree of freedom of 9. So that will give us the critical value. See, 9. This one is so we have right here 0.05. So it's 2.262. It's a critical 2.262. Yeah, 2.262. That's plus. That is plus or minus as a matter of fact because it can be either side. Okay, let me see it. Okay, plus or minus right here. I haven't forgot what I found. Okay, Gambo. I forgot what I just saw. Anyway, let me go. Let me go back to the tables. Get it again because I forgot the number. 2.262. 2.262 is the critical value. 2.262. 2.262. So that means minus 2.262 and 2.262. Now let us run the test. For this one, this will have the value. The test will have our hypothesis stated. We have our alpha, have our critical value. We have the summary statistics. Let us get the run the test. So let me make sure I have everything here. Oh, I got it. This is 400. This is 400. Oh, 24,000. Sorry, 24,000. Okay. 23,000. 24,000. Okay, I got everything right. Okay, let's go and put the test in. So we go to that our workbook. Instead of Z9, we're going to write T equals okay, X bar. Excuse me. I may stop here. X bar something's wrong with this. Okay, let me start all over. Okay, I'm gonna put right here. So I'm gonna put X bar minus mean divided by the standard deviation. Okay, standard deviation over, which is the standard deviation of this, by the square root of n, which is putting the numbers in again to refresh your memory. Remember, these are the numbers we're working with here. N, mean, sample mean, standard sample standard deviation. So let's just go and put them in. Okay. All right, we got this. S bar is 3,450 minus mean is 24,000. The sample standard deviation is 400 square root of n. Okay. N is 10 equal. So let's go and put this in the calculator. Z equals 23,450 or 2,400 divided by 400 for root 10. Okay. So let's put this is on. So we got put our calculator. So we got 23 450 and now 24 yeah divided by 400 about the square root of n, square root of 10, negative 4.35, negative 4.35, negative 4.35. Okay. So I'm gonna go and put it right there. Main workbook. Or let me copy it from here. Put it here first. Negative 4.35. Now copy this. Okay. I'm going to put it on the main workbook. Negative 4.35. So now, again, we have run our tests. We have our hypothesis stated, presented our summary statistics, get our critical value. Now, this is answer is negative, so we consider negative critical value. Okay. So you have Negative 4.35. So we're gonna be using the critical value of negative 2.262. Now let's make a decision. Our critical value T alpha over 2, this is the two-tailed test, equals negative 2.262. But we'll be using the absolute value of that, which is 2.262. Okay. So what, I'm sure you have learned absolute value in your when you are in doing your algebra. Absolute value goes like this. The absolute value of a positive number is, of a negative number is a positive number. Okay. So now we'll repeat the same process for the critical value, which is sorry, for the answer, negative 4.35. Calculated value. Calculated T equals negative 4.35. Yeah. Which can also be deceived by negative 4.35. The absolute value of that. Maybe, you put the symbol. I can get right here. Let's see, this is absolute value of that. Okay. Is also 4.35. So our answer is bigger than the critical value. So we reject. But before I do that, I want to show you something. Why we're using the absolute value. Now, if you have let's say you have the diagram here. Okay. For this, you have negative 4.35. Zero 4.35. And then you have let's put this diagram. I have it from here to here. Okay, and then you put your charts. Okay. All right, let's see. And then I move this. Okay, I make some adjustment to this so we can put the center line. Okay, make sure you're seeing this. Yep, I'm seeing it. That's where we are. So put the center line. Okay, and then your number that represents the critical value. So shade both sides. I think I put the numbers, the wrong number. I should put the critical value, not our final answer. So I'm going to correct this now. So I should put in critical value is 2.262. Sorry, negative 2.262. Negative 2.262. And the same thing here, positive 2.262. 2.262 as the critical values. So we have, again, let me make sure you're seeing it. So let's do this side as well. Okay. Okay. All of this maybe. Now we have it. Now you can see that our answer is negative 4.35. This negative 2. You can see that negative 4.35 fell in the rejection region, which can be here can be negative 4.35 is see on the left going left. I'm saying negative 4.35. You can see that this number fell inside the rejection region right here around that spot. See? So that's why either you draw it this way to show that it's bigger, or you just use the absolute value to reject. You know, so that means we reject now we can say the calculated T is negative 4.35, which the absolute value is 4. Sorry, the calculated T is negative 4.35, in which the absolute value is 4.35, and the critical value is negative 2.262, of which the absolute value is 2.262. So 4.35 is bigger. So we can now say reject HO because the calculated value of negative 4.35, of which you know that we use the absolute value. Algebraically, it's not less than that if you use them negative, but that negative sign is just to tell you that it is on the left side. That's all. Is bigger than, of course, you see, like I said, absolute value of, that means absolute value of 4.35, okay, is bigger than the critical value of negative 2.262. So, of course, you know that in algebra, this one is bigger actually, but like I said, you're using the absolute values. So we reject because our answer is bigger than critical value. So now let us make our decision. Conclusion. So since we are rejecting HO, this is a HO right here. That's that the mean equal to 24,000. It's claim. It is a claim. Yeah. So we are rejecting it. The not hypothesis. That means this one is the correct one. So that means that there is not enough evidence to support the claim. And what is the claim? That the average salary of nurses in 2000 is 24,000. Okay. So it says here, since we rejected it, we can say there is not enough evidence to support the claim that, okay, the salary of nurses during that year is 24,000. Okay. So let me show you again. First of all, you state a hypothesis and identify the claim. Provide as much statistics. Go to get your critical degree of freedom. Then go to the table to find the critical value on that student T distribution. Then run the test. Answer, when you run the test, you get negative 4.35. You compare them with the critical value. If it is bigger than critical value, you reject. If it's not, you don't reject. So that's it. Any question on this? Any question?
No, but I do have a question. I don't know if this is the end of class, but I have a couple of questions for you, Professor.
Yeah, when we finish, if it's not related to what we are doing here now, then when we finish, you can ask me here.
Yes, sir.
Okay. Now, this one is another example. In this case, all you have to do is to say here, an educator claimed that the average salary of substitute teachers in a district in Allegheny County is less than $60 per day. A random sample of 8 school districts is selected, and the daily salaries are shown here. Is there enough evidence to support it? Just like the other one, but the only difference that they just give you the numbers. They didn't give you the mean and the standard deviation, which means that you have to calculate them by yourself. Once you get them, you can now do the same thing what we did here. So you state your hypothesis, then calculate the mean. Now I showed you how to calculate the mean at the beginning of the semester using the formula. I also show you how to find the mean during the Excel assignment. We did the Excel assignment to show how to find the mean and the standard deviation. You can use that method to find both of them, and then state your hypothesis here. Go through the same process that we get to. And we're going to be using TDT's table because if you look at this, you can see that N is small. 1, 2, 3, 4, 5, 6, 7, 8. N is 8, only 8. See? So it's less than 30. And we don't know the value of the population standard deviation. So we have to use the sample standard deviation. So that's the only difference between the two. So follow the same method. You can do that at a practice. Type in the numbers in the Excel, find the mean, write them out, find the standard deviation, write it out, state your hypothesis, and repeat the same thing we did here to find out to test your claim. If there are any question before we finish for the day? Any question before we finish?
No, but I'll send you that email right now with the assignments that I need to do.
Okay.
Yes. Question. I have questions, multiple questions.
Okay.
Thank you, Professor.
Oh, you're welcome. You're welcome. So if you don't have any question, then feel free to.
Professor, I do have one actually.
I have
So let's start with this. Let's start with the person. There's somebody say that he have a more
Okay.
couple of. Let's start with that person. What's the name?
It's Anna.
Oh,
Anna.
Who?
Anna.
Anna. Okay, Anna Seller. Okay. What is your question?
Eli. But my question is, so the last class you marked me absent. I had got an absent for it, and I was there. And then my next question is,
I remember I saw you, Anna. So this is Anna Seller, right?
Yeah,
Yeah, I remember I saw you last class.
yeah, but you marked me absent.
So it's an error. So I'm gonna correct it.
All right. And then my next question is, so with when I was doing the Excel and stuff like that, I couldn't find like how when you did with the Excel assignment, and you was telling us to go to data and then go to data analyze it. Yeah,
Analysis.
I didn't have that on mine. Yeah, I didn't have that, and I couldn't find it, and it was like a little. So I didn't do the Excel assignment because it was just confusing. I got frustrated, and I was like, you know what, forget this. Like I looked everywhere. I even tried to
see that problem can be solved now. See, look, watch me. If you don't have it,
I had the same issue and I didn't do the assignment either.
Okay,
So
hold
can
on.
you show me as well?
I'm showing, but can you see? You can see the screen here, right?
I can see
Yes.
it, yes.
Good. If it is not in your if you click on data, let me remove it first. Okay. Sometimes it doesn't come with the this so please can bring it up. I will remove it by my own and then show you how to put it back. Okay. Okay, then go. Let me uncheck it for my own. See, now when I click on data, now you can see that I don't have it here. See?
Yes.
Good.
Mhm.
To add it, just go to File. See my hand? File.
Yes.
Then go to Options all the way down. See Options? Can you see it?
Option.
Can you see-
Yes.
Click on that. It will bring up this dialog box.
Hold on, Professor. Hold on. I'm sorry. Go to File, go to Option, and then it should bring up a dialog box. Okay.
Yeah, then you go to where they have the add-ins in the dialog box. Add-ins, click on that. Then you go all the way down where you can see where it says manage. See?
Mm-hmm.
On the right side, you can see where you have go. Click on the go. Then you can see the add-ins here. One is the analysis 2-pack. Check it. And then check the second one here. Once you do that, once you check both of them, click OK. Then you can see that it will appear there. To be there now.
Right.
So now you have two options. Either you do this and add it, or you can use a different computer. Maybe somebody's computer or library computer to do it, but it have to be done on Excel. Okay.
Okay. Yeah, I didn't have it. That's why I couldn't do it. And and I didn't know how to, so it was a little frustrating. But okay, so that was that. And then the next question is because
Thank you.
it was so much. Thank you, Professor.
You're welcome.
For showing us. Okay, so you had so much stuff that was due all at once. So I didn't, because like I said, I was struggling already with the Excel assignment because I couldn't find it, find the data analyze and stuff like that. So I thought it was the right homework I was doing, but I was doing homework 8, so homework 7 ended up closing, so I wasn't able to have a chance to even do homework. It's homework 7, I believe, right? Homework 7 on the on Alex.
You mean for this week?
No, that was due. Yeah, that was due last week, not this week.
Probably.
Hold on, let me go to it. I can tell you. Hold on 1 second.
Let me open it from here. Say last week, my announcement, I can get it from my announcement. My announcement for last week was week 13, and the homework we have is homework 7.
Yes, okay, yes. So it was homework 7. So I wasn't able, because I thought I was doing homework 7, which I was doing homework 8, because homework 7 had closed because it was already 11:59. So I didn't do homework 7. So I'm wondering if you can open it up, because that was the only 2 things that I didn't get to do was the Excel assignment and homework 7.
Well, you know that we have a deal that this week, if you have the attendance score is up to 70%, you can request for makeup for up to 5 assignments. So this is your chance. So you send me the email. Each of these homework that you want to redo, including this one you mentioned, have a name. Write the name. Then this weekend when I'll be opening it this weekend, I'll look at the attendance score. If it's up to 70, then I'll open it for you. Hello, Can you hear me?
Yes, yeah. I can hear you.
Mm-hmm. And so the other question, somebody else wanted to ask a question.
Hi, Professor. I wasn't asking, but I do have a question. I just wanted to know if I could set up a office hour thing with you.
Of course, but not this week though. This week is full.
No, it doesn't. So when will work for you?
Next week we get probably Thursday, because I normally do it on Thursdays.
Thursday at what time?
5.
Thursday at 5. Okay. And
so send me an email a day before that day, so that I can, or 2 days before that day.
Okay.
All right. Any other question before we leave?
Yes, I just wanted clarification about getting my assignments reopened. So you said for me to email you today.
Yeah, the names, yes, up to 5, not more than 5.
So then I pick my own
But
assignments.
be sure that the attendance score is up to 50%. That will qualify you. Okay.
Okay. And I'll name the 5 assignments. Hold on, please. So I should name the 5 assignments in my email to you.
Yeah, of course.
Okay. All right. Thank you.
You're welcome.
All right. You said you open up these assignments, right?
For its individual basis, depending on your attendance score. So if you have up to 70% on the attendance, then you can request the choose the 5 assignments. If it is only 2 that you want, that you want to fix, then try the name of the amendment.
Wait. Okay, I'm not understanding. So are we writing you?
Don't say we. Don't say we. Say I. I don't do it for everybody. It's for
I didn't say. Okay, I'm not understanding. So am I emailing you the assignment I need you to open, or I'm confused with the
names of the assignment they want me to open for you.
But I don't have that email stuff that everybody got to communicate with you. I don't know how to do it. So
I
never
have
did it.
my email is in my syllabus. You don't, we're not talking about remind. Talk about email.
Okay.
Email.
Okay, so like in the box, the inbox and stuff.
Yeah, my email is in my syllabus. You can see this in my syllabus. Yeah.
All right. Okay, I just want to make sure. I think some of that group chat thingy. I don't have it, so I never knew how to do it. So I just never
That
cared
one,
to.
that's a remind is something different. Just for anything official comes through email.
Okay. All right. And you got me for this class, right? Because last time you had me absent, so I just want to make sure.
Say I said what again?
Do you have me for this class, Anna Selah? Do you have me for this class?
Yeah, I have you. Have a name.
Okay. I just want to make sure because you had me marked absent for the other class. For
Yeah,
last week.
I'm gonna fix it. I'm gonna sell it. Yeah.
All right. So all right. Yes, sir. So I'll be emailing you and stuff. So the homework 7. Because that's the only homework that I missed. Other than that, I did all my homework.
Very good.
That was yeah.
Very good.
And then the Excel stuff, I could always just turn it in. I don't have to email you for that because that's already still open, right?
The cell assignment.
Yes, it's already open, so I don't have to email you for it.
It depends on the
I can
one you're
just do
talking
it.
about. Which one are you talking about? Some of them are open.
Yeah, the Excel that you just helped us with the
Oh.
data. It's already open, so I could just do the homework and just the Excel assignment and just send it into you, right?
You cannot submit it now because it's closed. So if you want me to open it for you, you have to send me that email, include it in that email.
Okay, okay. All right.
Yeah, I think it's closed. I think I think it closed last week.
Oh, okay.
Yeah.
All right. Yes, sir. Thank you. You enjoy your weekend, Professor.
You too. You guys have a nice day. If you don't have any question, anybody else have a question for me? All right. You guys have a nice weekend.
You too.